我唔知喎，應該最多係銀咯。呢個你要 check 下喎，我唔肯定喎。 你係計幅幾多？GSP 你計到係
知道呢一個就係用佢 dimension 嚟計咗佢個 volume 出嚟，再乘翻個 water self weight 攞出嚟嘅數。之後就咁樣，跟住再計到 VME 嗰度，因為 VME 大4個 VTM 嗰種出咗數出嚟。
VTM 計都係0.43%，0.43好細。即係講0.4%定計到4%？
佢再我就0.00咁樣，跟住再乘8成。
我要幫你睇下先，而家未計其他谷嗰啲 research。
我諗我都有睇，不過因為我就唔係即係用嘅
其他谷都係有4%。
因為我覺得
其他谷你計咗幾多？除咗呢隻 data 之外，你呢度係計咗㗎啦。點解呢度計到4，嗰度計到0點幾？
我後尾我審視翻用嘅數嗰陣，好似咧，即係唔係有一個 table， 跟住嗰陣我用嘅係呢一度，不過後尾即係GSB 嗰陣好似係淨係要嗰個 solid 嘅位置，但我用咗呢個係應該係成個 mixture 嘅嗰個位置嚟，用成個 mixture 嘅位置，我就會計到下邊呢啲。但係後尾我哋唔需要，我後尾用翻即係一個 aggregate 自己嗰條。
係啊，應該係就用 aggregate 嗰個啫。嗱唔緊要，再傾，我想問先。OK。
係咪講貼士？
今日會講。Hello。聽唔聽到 ？OK。好啊。Okay, while I'm still marking on the grade for the midterm exam, I would just like to quickly go through the solutions for you. I think most of you actually have answered in the questions. You may not exactly answering the exact solution as I state here, but it doesn't matter if you have a similar meaning. I will still give you marks, so don't worry about that. In examination, actually it is the same way. If you can see something that you have some impression, you just write down the description or the function or explanation according to your own understanding, okay? And then if it is related, I will also still give you marks, so don't leave it blank, okay? Because I understand sometimes you may mention that there are quite many materials that you cannot memorize everything, okay? So for this one, I'm not asking you to memorize everything and then write down exactly the same solution as mine, okay? But of course, for some keywords, if you can write it down, then it is easier for me to give you the marks. Or if you want to use your own word and then to describe it, it is also okay. So it doesn't matter, okay? Just don't leave it blank, okay? Just put the things that you still in your mind, and then you can describe by yourself, okay? For the role type, actually, I think most of you can write down. Well, basically, for the urban area in Hong Kong, there are 4 types of roads. Say, for example, the first type is the trunk road, and then the function is for longer distance traffic movement between the main center of population and activities. So this is the purpose and then the name of the trunk road. And then for the smaller one, we have a primary distributor road. Basically, it's for traffic between centers within the main urban areas, forming a primary road networks. And then a further smaller one, actually we call it the district distributor. Actually, it is the primary road network and then the district within the main urban areas. And then finally, it's for local distributor roads. You give direct access from the district distributor roads to buildings and the land within the district. Okay, so if you can write down the name of the road, then already you can have the marks. For the description, if you can express similar meaning, then of course you will also give you marks. Okay, and then for the types of the junction, actually there are 2 types of junction. One is a grade junction. The other is grade separation junctions. It depends on the grade of the junction. Okay, if it is at the same level, okay, so we call that it is a grade. If they are actually separated into different heights, then we call that a grade separation junctions. Okay, so actually these are in the notes. So I think this one is quite basic, and then I think. Most of you actually can write down the names, okay? But of course, maybe sometimes, sorry, I don't know why it disconnected, okay? Okay, sorry about that. I don't know why it's being disconnected. Okay, for the second question, I asked you about the rigid pavement and then the flexible pavement. And then state the difference and then describe the scenario to use either of them. So basically, the difference can be in terms of the materials, can be in terms of stiffness, can be in terms of load spread properties and then suitable area and maintenance, of course. You may mention about the materials. Of course, one is actually for the bituminous material and then for the foundations. And then the other one actually it is a PCC, that means it's Portland cement concrete, and then for reinforcing steel. And then for the stiffness, actually for the flexible pavement, we will have a softer stiffness, and then for the rigid pavement, you have higher stiffness. And then for the analysis method, one is layer theory, and then the other one is the plate theory. Because one actually is the slab, the other one is actually layer by layer. And then for the load spread properties, for the flexible pavement, it is not very good, and then for the rigid pavement, it is better. Okay? So you just state some difference between the flexible pavement and then the rigid pavement. And then for the scenario that you use the flexible pavement, usually if the profile of the alignment, it has slight differential settlement. And then for those, actually, it have higher speed and then need to have easy maintenance scenario, then actually we will use a sort of the flexible pavement. Because you need to, if you use the so-called rigid pavement, you need to post up the road, and then you need quite a long time in order to reconstruct the pavement for rigid case. And then for the rigid pavement, basically it is suitable for the traffic where it is slow, and then the stationary, and then basically the traffic is stationary. Okay. And then, well, it is suitable where a certain local weakness of foundation, because actually the concrete can spread the load along or at a different location of the foundations. So it is also okay for the certain weakness of foundations. So these are actually the case that is suitable for flexible pavement and for the rigid pavement. And then for here, actually it is the maximum size and the nominal size of the aggregate, and then I give you the case here, and then ask you to find the so-called retained percentage and then the cumulative percentage of passing. And then for the maximum size, actually defines that the maximum aggregate size defined as 1/6 larger than the nominal maximum size. Okay. For the nominal maximum size, it's just 1/6 size larger than the first seal to retain more than 10% of the material. So this case, actually, you can see that if it is the case to retain more than 10%, then, well, for this case, actually, it is 14, okay? So right here, you can see that, well, the cases we have the seal size from 14 and then down to 0.075. And then you can see that the retained mass is actually from 182, and then the retained percentage is just actually equal to 182 divided by 1,140. Okay, so you will just retain percentage is equal to say 60%. Well, for the cumulative percentage of passing, you just use 100% minus the retained percentage. So for the first one, it is 84. And then for the next one, actually just use 84 and then minus 11.1%, and then you will have 73%. And then you have 73%, you minus 30.1%, then you have 59.9%, okay? And then you minus 9%, then you have 50.9%, etc. Okay, and then you do it one by one, and then you can get the answer, okay? Now I can see that some of you actually put the cumulative percentage of passing at wrong rows, okay? Some of you put 84 in the second row instead of the first row, okay? Now for that one, I know that actually your intention is still reducing the retained percentage and then put it on the right-hand side. So for that one, I will deduct a little bit, but I will still give you marks for that, so don't worry about that, okay? But please remember that for the retained percentage, actually it is the percentage that retained on the shelf. And then the cumulative percentage of passing is actually 100% minus, I mean for the first one, it's 100% minus the retained percentage, okay? So the next one, actually, you minus the 84 by 11.1%, and so on. You can find the cumulative percentage for different seal size, okay? So actually, I have already mentioned in the notes, actually it is one minus the other one that you can find for the answer, okay? Any questions for this? So you have one minus the other one, okay? And then for the next question is about the performance grade bitumen, okay? Now we have two types of bitumen. One is penetration grade, one is performance grade. Then what is performance grade bitumen? For performance grade bitumen is that it is according to, actually it is the grade of the bitumen is according to the performance characteristic, like for the permanent deformation, like for the fatigue, like the low temperature cracking in different environmental conditions. So for the grades of bitumen, actually it depends on the result of testing, okay? And then for the penetration grade, actually this depends on light softening test, like the penetration test, like the viscosity test result, okay? It doesn't mention about the performance of the bitumen. But for the for the performance grade bitumen, actually the grade will be depends on the performance. Now, for example, I asked you to use 64 minus 28 as an example. So a PG 64 minus 28 grade is designed to be used in an environment where the average 7-day maximum pavement temperature is 64, and then minimum pavement design temperature of -28. So for this one, you can see that the performance grade actually states explicitly the temperature range to be used. It is used in the 64 degrees Celsius and -28 degrees Celsius, okay? So it should perform well within this range, okay? But for the penetration grade, actually it doesn't mention about the temperature. It just mentioned about the penetration, the extent of the bitumen, like 60-70 penetration. It just mentioned about the penetration, okay? So for the same question, I asked you also name one of the consistency tests for the bitumen, and then discuss its function, okay? Now basically there are 3 consistency tests we have mentioned in our notes. So you can name one of them and then write down their functions, and it's okay, okay? So we have penetration test. For that one, actually, we have a needle, and then the needle will penetrate into the binder. Actually, it is to determine the relative hardness of the bitumen, okay? The second one we call that is the viscosity test of the bitumen. It actually tests the fluid properties of the bitumen, and it's a measure of resistance to flow, okay? Because if the more the viscous is the bitumen, then actually the viscosity will be higher. And then we have the softening point test, actually denotes the temperature at which the bitumen attains a particular degree of softening. So we want to know the temperature that will make the bitumen soft, okay? So for that one, we put the 2 steel ball. Each steel ball actually is around 3.5 grams, and actually the bitumen is put into the hot water. The temperature of the hot water will increase gradually until it cannot support the steel balls, and then we say that actually it is soft. It is the softening point of the bitumen. Okay. So you may name one of them and then tell me the functions. Then it is okay. Okay. And then for the stress of the pavement, now basically there are 3 categories. One we call it the fracture. The other one we call it the distort, and then the third one we call that disintegration. So for the fracture, actually can be further elaborate as the cracks and then spallings. For cracks, it can be generalized, transverse, and then longitudinal, alligator, or block. And then for the pavement distortion, actually you have learned that about for the distortion, it is actually the rust or corrugation of the surface. And then the last one actually is the pavement disintegration. Usually it is the loosening of the pavement structures. It is about the ruffling or stripping of pavement from the basement or surface polishing. We call it, this is the pavement disintegration, okay? So basically for the distress, we have these 3 types, okay? And then for the next one actually is the calculations. I think actually most of you can get it right, because this one personally I think it is not difficult. Hopefully you feel the same, okay? Because this one actually just follow the equations and then substitute all the necessary values. Then you can find for the thickness of the bituminous layer, okay? So for this one, I asked you about the CBR. CBR, I think you know that it is a California bearing ratio. Okay, if it is less than 5, then the relationship between Young's modulus and then the CBR is 16.2 CBR to the power 0.7. For CBR larger than 5, then it is 22.4 times CBR to the power 0.5, okay? And then in the questions, I let you know that the CBR value is around 20%. And then you are going to design a two-lane dual carriageway. And then the design life is equal to 40 years. Now I asked you to evaluate the Young's modulus of the subgrade. But because actually you can see that the value is 20, which is larger than 5, so we will use the first equation, okay? If you substitute the first equation, you can find that the E will be equal to 100.2. So if you just substitute there, you will find that the value will be this one, is 100.2 megapascal. So for this, you will use the so-called the vehicle, I mean the value for the chart 2, okay? And then, well, you use the AADTB, the design is actually equal to 50,000 because it is 50,000 here, and then you will multiply with the increment of the traffic. And then the design years, I mean the construction years is 4 years. So from that, you will find the vehicle is 52443 vehicles per day. And then actually it's a two-lane dual carriageway. So actually we have 44 and then 55 consideration. For one direction of the road, we consider that it's 55, okay? And then we assume that 65% of the traffic will use the slow lane. So we use 0.65. And then for the commercial vehicle here, we have the bus equal to 30%. So we just put it 30% here. So we just multiply all the things 0.67 and then multiply with 0.3 and then multiply with 0.55 and then multiply with the design daily traffic. So you will get the value 5625 something, okay? It is the vehicle per day, okay? Then actually, from this one, we have the commercial vehicle, and then we will calculate what is the cumulative number of the commercial vehicles in 40 years. So you have 365 times 5625, and then times this factor. It is the factors to calculate the cumulative number of vehicles. And then you will get it to be 104.6 million of the vehicle, okay? And then you will check whether your system or whether your road is okay to support the so-called number of vehicles. So you will have 365 times the number of design years, and then times the design flow of the length, and then divided by the coefficient for the traffic congestion. So after that, you substitute all the values, then you can calculate that the design capacity is equal to 408,000 vehicles. So for this one, actually, it is larger than your cumulative number of vehicles, so it is okay. And after that, you will calculate the equivalent axle values for determination of the thickness of the bituminous layer. So you will have the values 2.9 for bus because all of them are bus. And then you will have the WF, actually it is the render factor for the length. So for this one, actually it is 0.95 for 3.5 meter of the length. So you have 104.6 and then multiply 2.9 and then multiply 0.95. So finally, you will find that the number of vehicles is 288.2 million commercial vehicles, okay? For this one, actually, you will find from the chart 2 and then with the thickness of the basement of 300 mm. So you will find the thickness of the bituminous layers is around 430 mm approximately. Now it doesn't matter whether you got say 400 or 450. Don't worry about that. As long as you are using the same approach, I will give you full marks. So don't worry about that. And then if you write down the cross-sectional cross-section of the paper, you can write down the wearing course, base course, row base, and then sub base, something like that, to indicate the cross-section of the layers. Okay. Okay. So this one, I think it is quite straightforward. I think most of you can get the answer. And then finally, you have a question here. Actually, this question is quite similar to the one in the tutorial. You can see that a sample is found to have the following properties. And then based on these properties, I ask you to calculate the bulk specific gravity of the aggregates, the air void content, the voids in mineral aggregate, and the voids filled with bitumen. Okay? So here you will have the bulk weight of the bituminous mix, and then you have the bulk volume of the bituminous mix, the binder content, and then you have the coarse aggregate, fine aggregate, mineral, filler, specific gravity of coarse aggregate, specific gravity of fine aggregate, and then the specific gravity of mineral aggregate. And then I also give you the effective specific gravity of the aggregate mixture, and then finally the specific gravity of the bitumen. Okay? So for this one, actually, I've already discussed with you in the tutorial. For this one, first of all, you need to find the weight of the aggregates, because actually 5.5% is due to is from the bitumen. So this one actually is from the aggregates. And then you can multiply with the percentage, and then you can find what is the percentage for the coarse aggregate, fine, and then mineral, filler, as well as the binder. Then you can find all of them. And then you can find the volume of the coarse aggregate, fine aggregate, mineral, filler, and then the binder. And afterward, you will find the so-called GSP, which is the bulk specific gravity of the aggregates. You use all the aggregates and then add them together, and then you divide by the so-called the volume. Then you can get it to be 2.64. Then finally, you will have GMM. GMM is actually just the maximum aggregates value. Maximum specific gravity of the mixture. Then you just follow the equations, and then just use the PB, and then use GSP, etc. You just substitute to the equation. Then you can find the values of GMM. And then for the bulk specific gravity of the mixture, you just use the measured density and then divided by the water density. You use 1210 divided by the volume, which is 510, then you get the values of 2.37. And then just substitute the values inside the equation, then you can find the VTM. VTM is actually the void, the total void within the mix, okay? And then the second one is actually the void in the mineral aggregates. Actually, it is the amount of the voids in the mineral aggregates. And then finally is the void filled with the asphalt. That means percentage of the void actually filled with asphalt. So you can see that we have 70.78% which actually filled with asphalt. Okay. So this is about the quiz. Okay. So this one actually I will put it on the web later for your reference. Okay. And then you can take a look as a revision. Okay. Well, today I will talk about the last chapter. It is the lighting of the highway, and then after that we will mention about some key points for the examination, and then to facilitate your revisions. Now, for the, I think some of you cannot finish the second homework on time, right? So some of you actually sent me the request to extend the deadline for the homework. Okay, is it necessary? Okay, so to facilitate your study and then to let you have more time, how about to extend to this Friday? Is it okay? Okay, so I will change the submission deadline on the Moodle to the midnight of this Friday. Okay, it is 11:55 p.m. On this Friday. Okay, and then the lab report, it should be on the next Friday. Okay. So just let me know if you still cannot finish. But you know, I also need to submit the marks, so I can't give you too much time. So try to finish the assignment this Friday, and then the lab report next Friday. Okay. Okay, then we can talk about the last chapter of the highway engineering. Actually, it is about the road lighting. Okay, so actually for the previous chapter, you learned about the sections design, that is the thickness of the sections or the layers. And then afterward, you also learned about the way how to calculate for the vertical curve and then the horizontal curve when considering the SSD. That means the side stopping distance. Okay. And then you also learn about the sort of drainage design of the highway, okay? So what's remaining is about actually the road lighting. If you can think, or if you can go around on the road, you actually can see different kind of lighting system is applied on the highway. So how we consider the lighting and then how to arrange the lighting on the highway. So this is actually the lecture that we mentioned about that, okay? It is not a very lengthy chapter, so we should finish it quickly. So to mention about the lighting of the highway, the first term that we need to let you know is the luminous. The surface and the target are made visible by virtue of light being reflected from one or from it and entering the eyes of the observer. I think you know that actually in your eyes, actually it's a lens, and then you have just like a projector, okay? You need a screen and then you need some light and then project on the screen so that you can be visible of the objects, okay, in your eyes, okay? So actually you need light. The light have to be, to be on the object, and it should be reflected to your eye so that you can see that. So first of all, you have the so-called illuminous. This term we call it the illuminous. Actually, it is refers to the amount of light reaching to the surface per unit of area. However, it can give no indication how strong the visible or visual sensation will be and how bright the surface will appear to the driver. The illuminous just describes how much amount of light to be given to or to be reached on a given surface. However, actually how you can see from the surface, it depends on how much light reflects to your eyes. So actually the surface luminous, not illuminous, is luminous. Luminous actually describes the amount of light radiated by the surface in an angle of the driver. So actually this is actually the way how to describe actually how much light is being reflected by the surface and then be directed to the eyes of the driver. So illuminous actually mentioned about the amount of light to be given or to be reached on the surface. But luminous actually measure about the amount of light radiated by the surface to the driver eyes. Okay? So luminous, the L is actually equal to E times the Q. E is actually recorded the luminous on the surface. That means there's the amount to be given or to be reached on the surface. And after multiplying with a coefficient, we call it the luminous coefficient, that actually measure the amount of light reflected by the surface to the direction of the observer. Okay? So of course, the luminous will be depend on the illuminous. But actually there will be a coefficient to be applied to the illuminous. That means not all the light actually reaching the surface will be reflected to the eyes of the observer. So this picture may give you more information about illuminous and then the luminous. So illuminous, we call it lux, is actually the amount of light reaching a particular surface. Where the luminous actually is the amount of light reflected to the eyes of the driver. Okay? So of course the luminous is related to illuminous. But of course, it is also related to the surface of the road. Some of the surface of the road actually have higher coefficient. That means more light can be reflected to the driver eyes. Some actually well, it's not good, so less light or less amount of light will be reflected to the driver eyes. And then for the luminance, since the brightness is finally determined not by illuminance, but by the luminance. So the visual performance and the visual comfort of the driver are directly influenced by the complex pattern of the luminance existing in driver's view of the road ahead. That means how you arrange your lighting source actually is important. Because actually illuminance is actually the way how the light will be generated. You may be generated into different patterns so that the luminance will be good enough for the driver to see the road ahead. So to design for the traffic roads, actually we have 4 important parameters to be considered. So for the first one is the average road surface luminance. It is actually the average of luminance at all testing points. Now later you can see that in order to check the luminance of the points or on the road, we will actually test or we will actually check the luminance at different points in the road. And then for LAV, actually it is the average road surface luminance. And then we have a number of checkpoints to take a look to the luminance on the road. And then this value is actually the average from all the testing points. For the overall road surface luminance uniformity, actually defined as the lowest luminance at any test point to the average road surface luminance. That means it's the lowest one and then to the average road surface luminance. So it is actually the over the LAV, the lowest luminance at any point and divided by the average road surface luminance. And then the third parameter that we consider, we call that is longitudinal road surface luminance uniformity. It is actually the ratio of the lowest to the highest luminance found at the test point on a line along the center of a single lane line. Well, for testing of a road, actually you will see that later. We will have different testing points, and then we will test it along the center line of the lane. And then this ratio is actually the lowest to the highest luminance found at all the test points on a line along the center of the single lane line. You can treat it as actually the lowest to the highest. The second term for overall road surface luminance uniformity, actually it is the lowest to the average. And then of course for the first one is actually only the average luminance, okay? So we consider the average, the lowest to average, and then the lowest to the highest, okay? And afterward, we also have one, we call that the Figure increment. Now, I don't know whether you have an experience, if you are walking outside in the night time, when the light actually has a particular range, or the amount of light is not very, or is very strong, sometimes you cannot see the environment clearly. I can show you the thing like that, like in the figure A and the B. It is in the normal condition. You can see the road clearly. But at a particular amount or the strength of the light, you will see that actually the environment is just like there's a cover of fog, I can say that. It is not very clear for you to see the road. And then we can call that is a glare conditions. It is actually at a particular level of light that actually it will make you to have a blur visualization of your road. You cannot see it clearly. So to measure this one, actually we use the so-called the Fred-Pol's increment. This Fred-Pol increment is actually equal to the equivalent luminance over the average road surface luminance. So you can see that this is the glare. So you cannot see the light clearly, and then divided by the luminance. Then actually this is the so-called TI. TI is actually the values of LV over L with the factor of 0.8. So when we consider the road lighting system, we need to consider these four different considerations. It's actually the average road surface luminance, overall road surface luminance uniformity, the longitudinal road surface luminance uniformity, and then about the Fred-Pol increment. So you can see that, as I mentioned, well, the left-hand side A is actually a CAD photo, and then the right-hand side actually is the real situation. For this one, you can see that it is clear for the photo, and then there's not seems like a layer of fog, okay? But for the C and D, actually it is in glare condition, so you cannot see it clearly. So actually we call that the veiling luminance. We have a contrast reduction. We don't want this situation to happen, and then we need to consider the so-called Fred-Pol's increment. So according to the code of practice BS-EN 13201, we have the so-called measurement to measure the luminance in the road. Well, I just like to let you take a look right here. And you can see that this is the observer right here, okay? Or this is the machine that we'll put here to measure the luminance. And then the first pulse of light will be here, and then the second pulse of light will be here. And then you can see that the height of the observer is around 1.5 meters, and then the distance between the first observer light is 60 meters. Then actually you can see that the observation point actually is in the middle, or in the center of the length. And then, well, we have different observation points. One cross is actually one observation point. So actually you can see that there are so many measuring points, and then we need to measure the so-called the luminance at different locations. So we can get all the values, like the average, like the minimum, like the maximum, according to all the points here. And then you can see that we'll put the first luminaire and then the second luminaire at some designed location. And then we try to measure the luminance at different points. So for here, actually, the average luminance, the overall uniformity, and then the longitudinal uniformity actually are calculated from an observer located at the center of each lane. The lowest calculated values of LAV, U0 and UL, and the highest value of TI shall be used. So if you use the LAV, U0, UL, and then the TI, and then to considering the design of our road. Well, actually, as I mentioned, for the major road, actually an average road surface luminance of 1 CD per meter square is proposed. This is actually the luminance of 1 CD per meter squared. And then for the residential streets, an average of illuminance on a row of 2 to 4 lux is proposed. But however, it is very difficult to assess the row luminance in the design stage. You don't know how much of the luminance in the design stage actually. Then actually how you can arrange your light. Although you want your luminance to be 1 CD per m squared. Well, the rule of thumb is that if the luminance, the illuminance is known, then for dark row, the illuminance divided by 20, it becomes the luminance. And then for normal aspect row, you just divide the illuminance by 15, then it becomes the luminance. And then for the light color row, actually just divide by 10, then it becomes the luminance. So from the illuminance, then actually you can calculate for the luminance from the rule of thumb. Okay. Of course, it's not exactly the value, but you just divide the illuminance by values of 20, by 15, or by 10, then you can find for the value. Then, as you can see here, we have different lighting class requirements. First of all is the maintained average luminance. So you need to calculate the luminance or the average luminance by checking the luminance at different points, as I mentioned before. Then the LAV have to be within 2 to 2.25 for the L1, and then to be between 1.5 and 1.7 to be L2. And then you need to satisfy all the requirements right here, depends on the lighting class here. And then the overall uniformity ratio is around 0.4 for the four types. And then for the fifth type is 0.35. While for the longitudinal uniformity ratio is 0.7 for L1 and L2, and then for L3 and L4 is 0.6, and then for the L5 is 0.4. For the threshold increment, actually it has to be less than 10% for the L1 and L2. For L3, 4, and 5, it has to be smaller than 15%. So this is actually the requirements of design of the row for the lighting. Okay. So you have the requirement for the average luminance, for the overall uniformity, longitudinal uniformity, and then the threshold. Okay. Well, why we need to have those kind of consideration? Well, here it explains the reason. The average luminance, why we need to maintain a certain value, actually it is to ensure that the carriage A is sufficient bright to reveal objects adequately. So for the average one, need to maintain. Actually, there's sufficient amount of light to be reflected on the road. For the U0, actually, as again, it is just the minimum to the average value. So actually, no part of the road surface is so dark that it becomes ineffective as a background for revealing objects. So actually, for this one, the minimum value divided by the average value, it actually does not let it to be too low. I mean, the value to be too small, so it is too dark for the driver to see clearly. And then it also has the so-called the longitudinal uniformity ratio. And this one, as you know, it is just the minimum to the maximum luminance along a line through the observer position. Why we need to consider that? Because actually to ensure pronounced visual pitchiness of the light roll surface is avoided. And then finally, it's about the glare, visibility glare. That means it is the reduction of contrast of the environment by the light. Well, actually, this phenomenon will reduce the contrast between the objects. So we have to recommend TI limit, and then to ensure that the glare will not impair the vision of the roll shape. So actually, that's the reason why we need to have these 4 parameters consideration. Okay. And then this lighting requirement is actually stated in the guided notes in the highway department. He mentioned that for the rural road, actually, if it is an expressway, then it should actually design as the L1 lighting class. For the trunk road, with speed larger than or equal to 70 larger than or equal to 70 km per hour, it has to be in the light class or lighting class of L3. If it is smaller than 70 km per hour, it has to be L4. And then in the rural road and then in the feeder road, actually the lighting class are L4 and L5 respectively. And then right here in the urban road, again, we have the expressway, trunk road, and then primary distributor, and then the district distributor, and local distributor. And then you can see that they are actually assigned to different grade here, from L1 to L4, okay? So from L1 to L4, you can see that actually these are the requirements, the lighting class. Depends on the type of the road, actually you will refer to different lighting class, and then you will know what is the average luminous, overall uniformity, longitudinal uniformity, and then the threshold input for the road. For the lighting, actually depends on the width of the road. It has a different arrangement. Say for this one, we call that a single side arrangement. A single side arrangement is used when the width of the road is not more than the mounting height of the luminaires. That means if the height of the luminaires is equal to 5 meters, then actually the width of the road does not wider than the height. That means it's a 5 meters. You can see that for this type, actually all the lights are arranged on only one side of the road. Well, you can imagine that for the near side of the post, actually it is lighter than that one away from the light. Well, the advantage of this one is actually provides a good visual guidance of the road, and it also provides good longitudinal uniformity to driver. So this one, I think always you can see in Hong Kong. It is for a single side pole arrangement. And then if you are on the road, you can also see that sometimes you use stagger arrangement. Stagger means that actually sometimes it happens on the left-hand side, sometimes it happens to the right-hand side, and they actually appear alternatively. Okay? So when we use this arrangement, is that the stagger arrangement is used when the width of the road is between 1 to 1.5 times the mounting height of the luminaires. Say, for example, the height of the luminaire is 3 meters. Then maybe the width of the roll is 3 meters or 4.5 meters. Okay. Then we will use this kind of staggered arrangement. Now, for the luminaire, that means the pulse of the light of this type actually it is on both sides of the roll. Actually, it is in a stagger or in a zigzag fashion. So for this one, actually, the uniformity of the lights is not very good because actually we have alternative bright and in the dark patches to produce. And actually it may not be a very good arrangement. And then it may cause some kind of uncomfortability for the driver. Then instead of so-called the stagger, they can use a so-called oppose. The oppose arrangement is actually similar to stagger. But actually you can see that the lights are facing to each other. Usually for this arrangement, it is for the width of the roll is actually larger than 1.5 times the mounting height of the luminance. So actually you can see that the luminaire or the light poles are opposite to each other. And then usually it is recommended for the wide carriageway or the expressway. Now for the dual carriageway, actually you can also see the arrangement like that. We call it the twin central pole surface. And then you can see that the lighting column actually are located on the central reserve. And then each lighting column actually normally accommodates 2 luminaire in a back-to-back orientation, each side of the carriageway. The advantage of this one is to reduce the capital and then the maintenance cost. However, it should be given to its potential hazard during mobile operation or the lane closure for lighting maintenance on fast lane. And then the next one is actually, we can call it the twin, central, and the opposite. So you will have twin at the center, and then at the same time you will have opposite. So like this one, you have twin luminaire located on the central reserve, and then you also have single poles actually on the other side of the road. So for this one, actually, it is recommended for expressway with exceptionally wide carriageway. Then we will have the so-called the twin central and opposite. So the lighting one is not a very long topic. So it is up to here. So any questions for this lighting system for the highway? Okay, if not, then we can take a short break, and afterward we can come back and then to a further discussion.
In the previous years, we can access the examination database
Yes.
in Google, but how come this year we cannot access it at all?
You cannot access?
It asks us to enroll to the class, to the course, but if we click enroll now, we are not permitted to enroll. So we cannot access the past data.
But I think there should be a database in the Moodle.
Yes, I'm talking about that database.
You cannot access the database?
Yeah, the database that includes the past papers.
Is it because of the maintenance or,
No.
or it is not accessible for everybody?
Yes, so it's not accessible anymore.
Really?
Before, we can just click it without being
Did you send email to ask the Learning Commons?
I don't know.
Because actually it is maintained by the Learning Commons. Learning Commons is the library. So we actually submit all our past paper to Learning Commons, and actually they put it on the Moodle. So I'm not quite sure about the validity of the past paper. If you cannot access, I suggest you may send email to Learning Commons. Learning Commons.
Okay, sir. Thank you.
Okay. Okay, can you hear me? Okay. I just would like to mention one thing about the arrangement in the next semester. Now maybe we will have one module, most likely is the project management, which I think may be run or may be launched in the Ethernet, okay? So one module will be launched in the Ethernet, okay? Actually, it is for EC to invite the speakers and then to come, maybe just one module only, okay? We will let you know the arrangement later, just one module will be run in the Ethernet, okay? And then for the some of you actually 即係講中文啦，下個 term 咧有一科會喺夜晚温嘅一科，我諗而家 most likely 係 project management， 咁啊同你講一聲先 ，OK？ Then I will say that for the examination, I think some of you are actually concerned whether you are able to take a cheat sheet, or I can say that it may not be cheat sheet, maybe additional supplementary worksheet by yourself. Okay, now you are allowed to bring one A4 paper. Okay, and then you can write it on both sides. Okay, about anything as you like. Okay, but just one. Okay. You may bring it during the exam. Just write down one, we call it maybe a supplementary worksheet or supplementary information sheet by yourself. OK， 你可以帶一張紙 A4 紙，任你寫乜都得兩邊。OK。So for that one, is it clear? OK， 一張 A4。OK。And then for the examination, actually, I just would like to mention that there will be two parts. The part A actually weighs for 32 marks. Basically, it's about some short questions. And then for the part 2, or we can call it the part B, there will be 68 marks, okay? So for that one, you have 5 questions. 5 questions. So one side you have around 30 something, and then the other side you have 60 something. Okay, totally it counts for 100 marks. Okay. So for that one, for the examination, I will let you know some of the important areas and actually which can facilitate your revision. Now, what I mentioned here is actually some relatively important, and it doesn't mean that for those one or for those things that I haven't mentioned are not in the syllabus. Okay. I just mentioned something relatively important, okay? And it doesn't mean that the things that I didn't mention are not appear in the examination, okay? You know what I mean? 唔係話我冇講嗰啲就唔考啊，不過我同你講嗰啲係比較重要啲嘅 ，OK？ You know what I mean? Okay? Now for chapter 1. Actually, we have mentioned about the different kind of roles. Okay, let me share. Now, for chapter 1, actually, we mentioned about different kind of roles, and then we have a different kind of system. And then we mentioned about different kind of important points, like for the hard shoulder, like for the central reserve. Well, actually, if I ask you something like that, well, you just need to write down, just like in the test, and then write down something that in your mind. I don't think you need to have put everything exactly the same in the notes, okay? So maybe you can save some of the space in your cheat sheet. Don't copy everything of chapter 1 to your cheat sheet. Actually, you may just waste your space, okay? If I ask you something in chapter 1, okay, you may just spend sometimes based on the impression, okay, and then write it down, okay? Because I can say that most part that I want to let you know or test you in the chapter 1 has appeared at least. So if I really have something to ask you in chapter 1, you just based on your own understanding and then write it down. It should be good enough. Don't spend too much time on chapter 1. And then for chapter 2, actually, This one is the surface type, and then we have mentioned about the rigid pavement, and then we also mentioned about the rigid pavement. Now, rigid pavement and then the flexible pavement are always important. Well, you can see that actually we have spent quite a lot of time to discuss about the advantage and disadvantage. And then the advantage and disadvantage, as I just mentioned before, it is in the quiz that we mentioned about what is the advantage and disadvantage, and then the way how we will adopt them into different situations. So this is the important points, but already appear in the text. And then the next thing that we also have put quite a lot of time is about some of, say, for this kind of surfacing material, say for the gradation, and then for the SMA, and then for the varying cost, what's the grade of the aggregate that we used. And actually these are also important points. Because actually for the flexible pavement, the most important material is the varying cost, and then for the SMA, and then for the frictional cost. And then I also mentioned that the gradation of the aggregate for different type of the materials are important. So here, I think you should pay more attention and then spend some time to study about the varying cost, SMA, as well as the friction cost, the gradation, and then the way how they can resist the load. Okay. So this gradation curve, we mentioned about what is the dense grade, what is the open grade, what is the gap grade, etc. So you should know what are they, and then how to represent them using the gradation curve. Okay. These are actually, I think I have mentioned many times. Okay. So you should know what they are and what do they look like, okay, for the gradation curve. And also, actually, for the flexible pavement and then for the rigid pavement, we always mention about the failure mode. So basically, we mentioned about the fatigue crack. And then we also mentioned about the permanent deformation. So here, these two are actually also very important, because actually for the flexible pavement, our design is actually based on this kind of assumption to design for our flexible pavement. And then our thickness of the bitumen basically depends on this important assumption. So that our thickness actually, if you have got the one proposed in the highway department, you will not encounter this kind of failure, okay? Like the fatigue cracking and then for the permanent deformation, this should not be happening if you can adopt our design. So for this one, actually, you should be able to understand the importance. And then also for the rigid pavement as well, what is the failure mode, and then what is the way how they should design. So also you have some so-called design criteria for both rigid pavement and the flexible pavement. And then for the rigid pavement, we always mention about the edge, and then we also mention about the joint. So these are actually also important, because you need to know why you need to consider the joints, and then what are the function of the joints, why you need to put the joints there, and what they are. So actually you need to pay some attention to this kind of things, okay? So actually this is for chapter 2. For chapter 3, actually, it is for the flexible pavement and then for the rigid pavement design. Of course, we mentioned about the way how to calculate. Actually, for the way how to calculate, we just have the test in the quiz. We mentioned about those kind of equation, how to calculate for the thickness. These several steps actually, it is obvious that these kind of things will appear in examination again, okay? So make sure that you know how to design for this kind of sections, okay? And then how to draw the cross section, something like that. So this one is similar to that in the quiz. So you just follow the step and then you can find for the thickness. Okay? So the calculation is the main part. So you may take a look to the design for the flexible pavement. And if you have time, you also take a look to the rigid pavement. And then for the aggregates, we have mentioned about the maximum size and then the nominal maximum size in the quiz. So this one actually, you know the aggregates, the most important criteria to the aggregate is about the gradation. So I again would like to emphasize on the gradation, what kind of gradation usually you have, and then what kind of gradation will appear for different kind of bituminous material. So for here, actually again you will have your gradation, and then your gradation curve, void space grade, gap grade, open grade, etc. And then where will they use for different kind of bituminous material? Then you need to pay attention to those. And again, as I mentioned, you need to know about the gradation curve, okay? And then different kind of gradation will be used for different bituminous material. So please know about that clearly. And then you have some tests for the aggregates. So you may just at least briefly know what is the testing for the aggregates. And if I ask you, you can briefly mention about what they are and what they are going to test for the aggregates. Okay, so this is for chapter 4 aggregates. And then chapter 4 also for bituminous material. But right here for the bituminous material, we have mentioned about the PG grade and then for the penetration grades, okay, test. So for this one, actually, there are some other tests. You know that not just the penetration, I mean the consistent test. So there are actually also the agent simulation and then stiffness modulus test and then the rolling pin from oven. So for this kind of test, you should be able to describe them and then to know the purpose of this kind of test. Because the penetration, viscous, and then the softening form test already appear in the quiz, right? So in the exam, maybe the other one will be also important, okay? So also take a look to the stiffness modulus test for the agent simulation and then the rolling film drape over. So at best, you can describe the test and then the purpose of the test, why for that, and then you can describe the way how to perform the test. And then you also have these kinds of the dynamic shear rheometer test. So you should also take a look what are they, and then what is the way why they are among the fence. Okay. This one chapter, I just need to go back and then to mention. And I forget to mention about the foundation one. For this one, actually, for the road design, actually, you also need to mention about the foundation design. So actually, for this one, you have sand replacement test. For California, berg test, dynamic cone penetration, pop-proof filling weight, deflectometer test, and the resilient modulus test. But this test you should be able to understand, and then how to find for the values for this kind of test. But for this one, actually, I have mentioned about the degree of compaction. You need to know what's the degree of compaction. And then I have an example here, and then to let you know how to plot the dry density against the moist temperature and the moist content for the soil. So you should know how to find this curve, and then find the so-called the optimum water content for the soil. And then for the sand replacement test, I also give you an example, and then you should know how to find the bulk density, at least for the soil. Okay. For the CPR test, I think you should be able to tell how to find the CPR. You should be able to tell the procedures, because this one is actually a very important test for the foundation, especially for the road design. Because for the road foundation, actually, you know, we have the road foundation, and then we have our bitumen layers on the top. So this one is very, very important. And then you should know how to find for the CPR value. And then you have the remaining tests. Actually, for these, actually, you should be able to tell what are they and what's their functions. And you should be able to take a look, and then at least you can describe the test briefly. Okay, and then for the next one is this. The next design, actually, here we have mentioned that about the Marshall Max design. Well, actually, for the quiz, we didn't mention about the Marshall design, okay? So, as I mentioned, this one is again very important. If it does not appear in the quiz, then, well, you think it will appear in the exam? Okay, as I mentioned, it's very, very important. Okay, so actually you have to mention, have to understand what is the Marshall design, and then actually in the lab report you have already some practice how to calculate for all the values. Okay, and then how to determine the optimum bitumen content. Okay. Now make sure that you understand the concept in the lab report. It actually helps a lot, okay? make sure you understand the procedures or the calculation in your lab, okay? Because actually Marshall design, as I mentioned, you need to find out the several points or several things. Usually you need to find the bulk density, you need to find the GMM, that means the maximum specific gravity, and then you also need to find VFA and then VMA. I'm sorry, I just paused it. And then you need to find out the values, and then from this, you will calculate for the stability against the bitumen content, and then the Marshall flow against the bitumen content, and then the VTM against the bitumen contents, VFA and the VMA against the bitumen content. And then you will note that actually you have two ways to find for the optimum bitumen content. One is actually depends on the maximum density, maximum stability, and then for the air voids you divide by the 3, and then you will check for the optimum content of the bitumen, okay? Or actually there's another procedure, it's actually just depends on the air voids, 4%. And then you will find the optimum bitumen content, okay? Now after that, you find the optimum bitumen content, you will take a look, and then we check whether you can fulfill the requirements from Hong Kong. Because actually you find, say, from the average of the feed, then you will take a look at the optimum content. From the optimum content, you can back check the the Marshall stability, and then the maximum flow value, and then the minimum void, minimal aggregates, and then the air voids where they can fulfill the requirement in the scope of practice. Or I can say that it is the non-scope of practice, this is the specifications. Okay? After checking of the bitumen, optimal bitumen content, then well, we will look back on the table, you can back check for the stability, flow, and then the VMA to see whether it can fulfill the specification requirements, okay? So this chapter is also important, and then you should be able to calculate the optimum bitumen content by data, okay? So for the chapter 7, it is about the road safety distance. Now, for the road safety, actually for this one we mentioned about the horizontal curve distance. So we mentioned about the SSD, which is actually the braking distance plus the so-called reaction time, okay, reaction distance here. So from this one, it is the total stopping distance, or we can call it this is SSD, a safety stopping distance, okay? That means if you've seen something ahead and then you need to stop your vehicle, actually it is your reaction time times the design speed, and then plus actually the braking distance, right? So this one, you need to know about that. And then for the horizontal curve, as we derive, actually there's a distance right here, right? Then we derive that actually the distance. When you look at something ahead, of course it is a linear manner, but the actual stopping distance is a curve, right? So you will use this curve as S is equal to square root 8 times RV, and then you will find the speed of the vehicle. So you need to know how to calculate these kind of things. And actually, I think some questions has been asked in the tutorial, okay? So go back and then take a look to the tutorial and then to know how to do that, okay? So it should be helpful to your final exam. And then for chapter 8, actually, instead of horizontal curve, we have a vertical curve. Because again, when you see something ahead, when you cross the road, actually you will see something ahead. Well, actually, S is the sight distance, okay? And actually, you again need to stop your vehicle from hitting ahead. So always you need to find what is the length of the vertical curve in order you can stop your vehicle on time. So actually there are some consideration of this kind of vertical curve length, okay? And then in the tutorial, again, we have some related calculations, okay, about the length of the vertical vehicle and then the SSD, stopping sight distance, okay? And then you should be able to know how to calculate this kind of distance and then the related design velocity, okay? And then you also have some kind of this kind of things to find the points of vertical curve, points of vertical tangent, and the vertical intersection, etc. So you may also need to take a look to this kind of things, how to calculate for that, because actually there is some related calculation here, which mentioned about the setting out of the vertical curve. Because it is actually a parabola, and actually you can find the equation for that, and then you can find the related position of the vertical curve. And then for the drainage of the road system, basically you have a large part in the calculation. So for sure, you actually need to know how to follow the guideline from the lecture notes, and then to calculate for the drainage spacing for different cases. But basically, you have this chart actually summarize the way how to calculate. So basically, this is the summary of the calculation. Then you need to know how to follow this kind of instruction to calculate the spacing of the drainage system, okay? This one, I don't think it will be too difficult for you if you follow everything in the notes. But for the equation, it will be given in the examination. Okay, you do not need to copy the equations. But of course, if you like, you can still copy. Okay, but in the exam, basically I will give you all the necessary equations. Okay, so it should be good enough for you. For the design, I mean for the calculation. And then finally is the chapter 10 today. Because it is a new chapter for you, so you need to, of course, take a look. And then, of course, you need to know the important criteria for the design. You need to know actually for the road design, you have the basically, you consider some important concept, like the average road surface luminance, overall road surface luminance uniformity, longitudinal long surface luminous uniformity, and then the Phillips hole increment, etc. And then you need to know why you need to consider these important parameters, okay? there's some reason why we need to consider that, right? And then you also can take a look to the arrangement of the lights. There are several ways for us to arrange the lights, okay, in order to provide the necessary luminance on the road. Okay? Okay, so I think that you can prepare accordingly, according to the important points that I mentioned. Now, as I mentioned, some points I didn't mention, it doesn't mean that it won't appear in examination, okay? But I just mentioned some relatively important points for you to have your attention, okay, for the final examination preparation, okay? Now, I think today is the last lecture. And then hopefully you have a happy journey, okay, during this semester, okay? And then for this chapter, I mean for this subject, I can say that it is quite a lot of materials. But actually there are, well, many reference material. So don't worry too much. Actually, as I mentioned, if you don't know how to answer the questions, just based on your understanding and write something that is in your mind, okay? And then if it is close to the original paragraph or setting, I will still give you mark for that, okay? So just don't leave it blank, then it's okay. Okay? So I think I will end the lecture a bit earlier if you have no further question. So before I end the class, is there anything you want to ask? 有冇問題？有冇嘢想問？ But next week, there will not be any lectures, okay, as it is the last lecture today. But if you still have questions, you are welcome to send me email or send me WhatsApp, or you can even call me because I have a phone number, yeah, and then the WhatsApp number in the WhatsApp group. You can always reach me anytime, okay, if you have any questions. Now for the homework, I know that you are busy, so I will extend it to Friday. Okay, this coming Friday. I will extend it to 11:59 in the midnight of this Friday. Okay, so you don't need to hurry to finish it today. Okay, you will still have time for that. So any questions? Okay, if not, then good luck to all of you. And then next semester it should be face-to-face. So welcome you back to the eye. And then hopefully we have a closer contact in the next semester. Okay? Just let me know if you have any further question and any difficulty. Okay? 好，咁冇問題啦，隨時揾我啦嚇。email、WhatsApp、電話，有需要就打俾我 ，OK。好，咁遲啲再見啦 ，OK， 好，拜拜。